Hello everyone, my name is Fan Yang. I'm the technical marketing engineer for the Cisco CSR1000V. In this video, I'm going to talk about Azure Express Route and how to connect Azure Express Route with Cisco CSR1000V. This is the slide I take from the Azure presentation, but basically I think everybody knows what is Express Route. It gives you a dedicated line or dedicated access into Azure services. So the express route has three different type of peerings. So you can do with private peering. So you will be able to access your virtual network directly with those private IP addresses. It also supports public peering. So the Azure will announce the public IPs for their IaaS services and also their secure server, those Azure services public IP to on-prem. And the third peering is called Microsoft peering. So it will optimize the traffic going to Office 365 and Dynamics 365. So those are three peerings you can do with ExpressRoute. And in this video, I'm going to talk about how to do the peering with private peering. As you can see from this slide, the ExpressRoute also supports primary connection and secondary connection. I'm going to also talk about how to use the private and secondary connection with the Cisco CSR. Let's assume you have an on-prem data center that's running at the left side, and you are running a Cisco ASR1000 as the on-prem router, and you have your virtual network that's on the right-hand side that has your application Subnet, or you have your VM that's running in the VNET. Now you want to connect those two together. So you can create express route to connect your on-prem data center to the virtual network, which will give you a dedicated throughput, a dedicated bandwidth. The benefit of doing the express route with CSR is the CSR will give you much more enhanced networking features, like you can have more granular control of your routes, have a higher scale of the routes, and also the express route doesn't have the encryption capability, where the CSR can help you to do the IPsec encryption and also can help you to do traffic control, like prioritize the traffic, have the application or traffic visibility. So there are a couple of benefits you can get with the CSR. So the step is, first you have to talk to your service provider to create an express route circuit in your Azure account. You need to input the BGP parameters used for this circuit, and these BGP parameters basically will be used on the ASR side. So you need to configure those BGP parameters later. You might have multiple service providers. Say you want to have both AT&T and Verizon express route, then you can create multiple express route circuit, which will be tied to different service providers. The second step, you need to create a gateway subnet within the VNet, which you want the express route to be connected to, and then you have to create a VNG, virtual network gateway, in a gateway subnet. The third step is you need to add an express route connection on that virtual network gateway and specify the express route circuit you create in the first step. So basically you need to link the resource you create in the first step and the gateway you create on the second step together. And the BGP connection will be established from your VNG to on-prem router, ASR in this case, and then the VNG is going to exchange the virtual network setup block to the ASR, and also the ASR is going to exchange the customer data center setup block. So, and also after the VNG learn the routes from the ASR, it's going to program those routes to your application VM that's running in Azure VNET automatically, so you can check the effective routes, and I will also show this in my video or in my demo. The first step is now your CSR can talk to your ASR directly through the private IP. So then you can build another BGP connection in this case. You can either do multi-hop eBGP because it's already based on private IP, and this is only about 2 hops or 3 hops away So multi-hop eBGP should work, or you can also create a single hop eBGP over a tunnel. So because Azure doesn't support GRE or GRE packet will be dropped, so you have the option to do with IPsec tunnel for encryption if you need encryption, or you can do VXLAN GPE tunnel for non-encryption traffic. But just remember the VXLAN GPE doesn't support IS as routing protocol and also doesn't support MPBGP. The fifth step or last step is set up the HA between CSR1 and CSR2, and you can add a user-defined route to let your application subnet to use the CSR1 and CSR2 as a gateway or as a next hop. And then if one of CSR fails, your application gateway can still reach out to your, or the VM that's in the application subnet can still reach out to your customer data center VMs. So I'm gonna demonstrate all the steps in this video. So this is the setup details. Let's take a look at what are the IP addresses I'm using at the customer VNet. So this customer VNet is running 10.10.10.10/16. So this is a large setup block. So I divided into multiple subnet. So I will have a 10.0.0.0/24 as a public subnet, and I will have the 1.0 as a private subnet. Because I mentioned you also need to create a gateway subnet in this case to connect to your express route. So I create a random, basically you can pick any setup block or any subnet within that setup block. So I choose 200.0/24 as a gateway subnet. I really suck at choosing the IP addresses, but I think this is just give you an idea how those can be connected. You can change the IP address space based on your requirement or your scenario. And on the left side, that's the customer data center. I'm running a 10.11.253/24 network. And because there are 3 subnets within the VNet, the gateway subnet is not used by any of the VM. It is only used by the VNG, which is virtual network gateway. So the CSR will have 2 interfaces. So it will have one interface in public subnet and the other interface in private subnet. When I say public subnet, it doesn't mean it has to have a public IP address. It's more like public or the facing to your on-prem side, which is the left side. And on the right side, it's going to be the private subnet, which is talking to application directly. So we have 2 CSRs in this case. They are deploying different availability zone for HA, and the AS number in this case I'm using AS 65011 on CSR1 and 65012 on CSR2. On the ASR, I'm using 65002. The virtual network gateway or the Azure side actually is using 12076. So this is a fixed AS number on the Azure side. And there's a lot of IP address requirements on Azure. I put the link here. Actually, this is very useful link. So you should take a look at link. What are the IP address addressing requirement for you to set up the express route? Like you need to create a /30 subnet for each of the connection. If you remember, we have primary connection, we have secondary connection. So the first step, as I mentioned, this is more into detail. So this is the IP address I'm using, F88.0.0.0/30 as a primary connection. I have another 88.0.1/30 as the secondary. So the primary and secondary, even you only have one ASR, you can still create primary and secondary. But I think it's more useful if you have 2 ASRs that's running at your data center. But in this case, I'm using one ASR. I will still be able to show you the primary and the secondary. But just keep in mind, it's better to use 2 physical routers at your data center to have the high availability. The second step is I'm going to create gateway subnet, which is 200.0/24. And then I will build the first BGP connection. If you remember the previous slide, there are two BGP connections. So the first one is from the ASR to your virtual network gateway, which is sitting in the gateway subnet. After that, I'm going to create a loopback interface on the ASR. The reason for use a loopback interface is I'm going to use that interface to talk to the CSR as a private IP address, because I don't want to advertise any of the private IP address of my customer data center in this BGP1 connection. I want to advertise those private IP address through the second BGP to the CSR directly. After I create the loopback, I can use that loopback to create IPsec tunnel from the ASR to the CSR1, and also another tunnel from the ASR to the CSR2. After I create the tunnel, I can enable another BGP connection. In this case, it's going to be BGP2. And with this BGP2, I'm going to advertise the data center route to the CSR. And later on, so one catch here is, because from the ASR perspective, it will be able to see two BGP connections. So the first BGP connection is going to the virtual network gateway. The second one is going to the CSR. There's a catch. You need to put a static route on CSR1 and CSR2. So you need to put the destination as your loopback IP address 88.0.0.9, and then you point the next hop as an Azure internal gateway, which is the first IP address of the subnet. So it's going to be 10.10.10.1. You need to put that static IP route on both of the CSR. It is because you might see the arrow, like it will tell you the tunnel or the IPsec tunnel is temporarily disabled due to recursive routing. I also put a link there. The reason is because the CSR has already used a default route to reach out to the 88 subnet, the 88 IP addresses. And after the BGP connection has been established, it will learn that route through the BGP as well. So actually, it's going to use a more specific route to reach out to that 88 IP address. But actually, the previous connection or the underlying transportation is based on the default route. So that will make the route flap on the CSR. So the tunnel is kind of flap. And you will see that arrow. In order to work around it, so you can use route map to filter that route out of the CSR. So when the ASR is talking to the CSR, you can make sure it doesn't advertise the 88 IP address, or you can use a route map on the CSR side to filter that route out. The other way is you can create a static route on the CSR, so it makes sure it always uses the default route or the interface to reach out to the ASR, or you can use a different routing protocol. You can have BGP1 as your ASR to VNG, and then you can run like EIGRP or OSPF from your ASR to the CSR. So couple options to solve this issue. And in this case, I'm going to show you to use the static route here. And the last step is you can set up the CSR as HA mode in case of one failed, and also you can change the UDR on the application subnet side to make sure they are using the correct CSR as the gateway. So let's go to the demo. Before we go to the demo, let me show you this link. This is really helpful. Actually, this is right by Azure. So this is the link I'm talking about. So it walk you through what are the IP addresses used for peering, what is the used for private peering, what is the AS number you need to use for peering. So please go through this guide, and then it will help you to better understand how to set this up. So let's go to my dashboard for Azure dashboard. So as I mentioned, the first step is you need to create a circuit. So as you can see, I already have a circuit. Let me make it bigger. I already have a circuit that's running. It's provisioned. I'm using Econex. I'm based in California. Actually, I'm in San Jose, so I'm using the Silicon Valley peering location. If I click this circuit, you can see there's a connection already created. But basically what you need to do here is first you have to create this circuit, and then you have to choose to use the private peering, because I'm going to demonstrate the private peering. This is the IP address I already configured, and this is my peer AS number, and this is the primary subnet, which basically will be the primary connection, the secondary connection. You can use a shared key, so it's more like the BGP connection can be authenticated before the session has been established. I just trust the connection, so I didn't put any key, but for best practice, I think it's better to put a key here, so other people will not be able to connect to your direct connect. So basically, this is the setup we have now. I also mentioned we have a virtual network already created, and we can check what are the subnets. So this is the HA virtual network, but basically this is the network that has the express route. If we click the subnets, you're going to see I have a public subnet 0.0/24, private subnet 1.0/24, gateway subnet 200.0/24. I also have those CSRs already created. It's a Tunic CSR, so 2 CSRs give you Phoenix, and I have a CentOS that's running in the private IP addresses. You can see here, I also have an express route gateway created. So the express route gateway is the one I mentioned in the later step. It's virtual network gateways. So here, this is the express route gateway I created. So basically, you need to specify this is the express route gateway type. They have standard, high performance, so based on what is the throughput you want to use, or what is the throughput for express route. I'm just using the 50 meg. That's the cheapest one that I can afford. Okay, so this is the gateway that's already exist. If you take a look at the connection, so that's the connection I talked about. You need to create a connection after you create the virtual network gateway. And basically, this will link the virtual network gateway to your express route circuit. And as you can see, it's already provisioned. So now I've done zero config on the ASR side yet. So there's no peering, there's no neighbor existed. But let's go to the express route and let's check before we do anything to the router. So if you click the peering, okay, so here actually you can see get a route table, get a route summary. Let's see if there's any neighbor established or not. This might take some time, typically take about 20 to 30 seconds. It will show up what is the neighbor that has been configured. Is there any neighbor established or not? How long it has been up there? So it's going to tell you. So Azure offers some way to do the troubleshooting. Okay, so as you can see, those are the neighbors I created before. This is in idle. Those two, actually those are not the one I'm using. So because I mentioned I'm using 88 IP address. So that's my primary. Now, it says this is primary. You can do a show secondary actually. It's going to switch to 1 dot, and it's also idle, so which means there's no neighbor configured yet. So now I can go to my ASR and configure those configurations. So my ASR actually is running in a different place, so I need a jump server to log in. Okay, so this is my ASR. Actually, I already configured the IP addresses on the ASR already. because I have a switch that sits in front of the ASR, so I don't have to terminate the VLAN tag on the ASR. Let me see if I have done that before. Show run interface. Okay, yeah, so I have a switch that sits in front of the ASR. So when you create express route, you need to specify what is VLAN, because it's basically it's a .1Q trunk port, so you can have multiple express route with different tags. But I have a switch that terminates the tag, so I don't have to configure the tag on the ASR. If you don't have a switch in front of the your router, you can just terminate the tag on the ASR with the sub interfaces. So I already configured the IP address here, so we can pin the Azure side. So basically, the IP address is gonna use a /30 subnet, and the first available IP address need to be configured on your on-prem router, and the second available IP address need to be configured on the, or you don't have to configure that, but basically the Azure will take that. So let's pin the secondary. Okay, so we can pin the second IP of that subnet. Okay, so basically the connectivity works. So which means my ASR can reach out to the Azure IP addresses. So let's go back to the slides. The first step we need to do, as I mentioned before, is we need to create the first BGP connection that goes between the ASR and your virtual network gateway. Yeah, so that's the first step we need to do. I also make a sample configuration script here. So you can also find this script at the link of the video. You should be able to download this as sample config, and then you can change the IP address to suit your own need. So this is the ASR config I already put here. Those are the config you need to put. Basically, this is gonna configure the BGP connection from the ASR to the virtual network gateway that's sitting your VNet, and it's gonna enable or activate the neighbor. So let me copy the config. Come to here. Before we have that, let's do a show BGP all. We don't have any BGP running, so let me just copy those config. Okay, so now if we do a show BGP all, okay, as you can see, I can learn the routes from the virtual network gateway already. That's the 10 subnet, which is the virtual network subnet. If you do a show IP BGP summary, I have two neighbors. So let me make it bigger. Okay, I have two neighbors because I'm running a primary connection and a secondary connection on the same ASR. For the best practice, it's better to run those connections on different ASRs, so you have a physical redundancy. ASR1 has the primary, ASR2 has the secondary. But basically, I'm showing you can have a primary and a secondary connection. So those are the configuration you need to put on the ASR. So now, if we go back to the, let's go back to here. If we click show, okay, so this is primary. Now you can see this 88.0.1 status has become to 0. If we do a show secondary, yeah, it comes to 1. So basically, it's not idle at all. And also you can see the uptime, 45 seconds, this is 52 seconds. So it's basically, it means the first connection between the ASR and to a virtual network gateway is already up. And if we do, I think we have to do this before I should do a show BGP all. So this is an equal, so it's not an ECMP, but basically, because you have two connections, the ASR is able to learn the routes from both of the neighbor. The reason it is choosing this 88.0.0.2 is because it has the lowest router ID. Let's do this. Show PGP for unicast. I guess it's 10.0.0.0. Okay, so basically this will shows up the routes that's learned from different neighbor and what is the other matrix like local preference, origin IGP. As you can see, everything is the same except this is the router ID. So if you are familiar with BGP best path selection, the last rule is the lowest router ID wins. Because this is the same route, so the 88.0.0.2 is lowest router ID, so you prefer this one. As you can see, it has best. If you show IP routes, this 10 subnet is using 0.2. Actually, it's primary connection, and that's why the Azure also prefer the secondary connection IP address is larger than the primary connection IP addresses. That's for this reason. Okay, so we have done the first part, which you connect your ASR to the VNG with the BGP configuration. So the next step, as I mentioned, is the second. Actually, we have already done that as well. Like you create a gateway subnet, you create a VNG. So we have connection to BGP. So now we need to create the loopback address on the ASR. Okay, so let's create a loopback on the ASR. The reason to create a loopback address on the ASR is I want the CSR to talk to this loopback and then to establish the tunnel. You probably have the question, why to create a loopback? Can I use a physical interface on the ASR? Yes, you can if you have a separate interface and it's not used at your data center side. You can just use that interface IP address as well. Or you can use the interface that's between the ASR and the gateway subnet, but typically this is more like link local IP address. Nobody won't really use those two IP addresses, so that's why I create a loopback. But you can change those. So let's copy this loopback, and also we need to advertise this loopback in the BGP configuration. So let's go back here. Okay. So we already configured the loopback BGP. Let's show BGP on. Okay, so this IP address, this 88.0.9 will be advertised to the other VNG. Well, that's the first route we advertised through the express route connection. So now if we go back here, this is, I think we are at the route table summary. We can check, okay, get the route table. It's gonna show you the routes that's learned from the on-prem router, which basically is an ASR. So let's see what other routes it has learned. This probably take around 20 to 30 seconds as well. In the meanwhile, as we talk, to avoid the recursive routing issue that may happen in the later steps, let's create a static route to point back to this loopback IP address on the CSR. As I mentioned before, you can use other routing protocols, you can use route map to filter the route, but I'm just using this as the simplest way to do it. So let's log into the CSR that's running in Azure. So we have, okay. Oops, how come I can forward the password? So, okay, good. So we have the CSR, let's put, yeah, we can just put the static route real quick. So now let's go back to here to see if we have learned any routes. Okay, so now as you can see, we have this 88.0.9 route that has been learned from the on-prem router, which is 0.1. If you show secondary, you can also see the same routes has been learned from 1.1. Basically, that's a different IP address because that's the secondary. So that's basically what are those routes that has been learned from on the virtual network gateway. I think the other routes that's just that are Azure system routes. As you can see, this is the virtual network setup block. So basically, it tells the VNG if you want to reach out to the VNet, you go to this IP address, which actually those are the gateway IP address. Those are the IP address within the gateway subnet. So that's why, as you can see, you need to create a gateway subnet because basically it will use one of the IP address as a next hop to talk to the virtual network setup block. Yeah, that's right on this side as well. Okay, so that's the steps we have done here. So the next step actually is we're gonna, because after we create the loopback, let's just do a quick test to see if we can reach out to the CSR with this loopback. So let's take a look. What are the private IP address using on the CSR? Okay, so I have CSR 10.10.0.4. So let's try to pin this IP address from CSR 10.0.4 source loopback 0. Okay, I can pin that IP address. I can even pin a private IP address file 1.4. So that's the private IP. Show IP address brief on the CSR2. So basically end with 5. So let me just change those IP address to 5 to 0.5. Okay, the connectivity is there. Okay, everything's working. You probably noticed I have turned on 100. So I don't want to bore you with all the configuration I want to do because this is config I've done for the HA. I have a separate video to put HA, so you can go through that video to configure HA. But basically, the HA has been configured before I'm recording this video. So that's the HA tunnel. Okay, so now we need to create the IPsec tunnel from using this loopback IP address and talk to the CSR that's in the virtual network. Let's go back to my script. So as you can see, this is the secondary connection between the ASR and the CSR. So before we do that, let's check real quick on the prime side to see if we have the routes that learned from the CSR. So show BGP all. Okay, I only learned this route from the virtual network gateway, but not the CSR because I haven't configured the tunnel yet. So, and also because I'm gonna show you the end-to-end IP connectivity. So I have a VM that's running. Let me show you really quick. I have a CentOS VM here. So the networking. So the private IP is 10.0.1.6. The goal is this CSR, this ASR actually has a on-prem IP address. This is gonna be the gigabit 1. So the end goal is it should be able to reach out to the CentOS using gigabit 1. But now, as you can see, it cannot reach. So the connectivity is not there. So after I configure those IPsec tunnel, those BGP, it should be able to reach out to the CentOS from the ASR. So now let's go back to the script. Let's just copy the config real quick. So this config you need to put on the ASR. So basically, let me go through the config real quick. So those are the IPsec tunnel configurations. I'm using pre-shared key, Cisco, and also I think I'm using the tunnel mode. I have 2 tunnels on the ASR. So you have tunnel 1 going to the CSR1, you have tunnel 2 going to CSR2. So those are the IP address I'm using. You can change those IP address to suit your own need, but I'm just using those IP in my video. And the tunnel source, I'm using loopback 0, as I described before. The destination, I'm using the private IP or the public IP address or the GIPT 1 on the CSR in the VNet. So, and also I have the BGP config as well. So you can go through the configuration. Let me just copy the config real quick. Okay. Okay, so those config will be put automatically. But before we put the configuration on the CSR side, the tunnel is going to be done. So I think that's expected. Let me copy the config for the CSR1. As you can see, it's also pretty simple. It has the IPsec config. I'm using the pre-share key. Tunnel mode as well. I created one tunnel because it only talks to the ASR. And you have the BGP configuration as well. So that just to be careful here, or I'm doing a network on the CSR because the CSR in this case it has a left-hand side. It's a public subnet. Let's talk to the virtual network gateway. It has a private subnet talk to application subnet. So I want the ASR to use the CSR to reach out to the application subnet. So I advertise this subnet directly on the CSR. Actually, both of the CSR has this subnet. So I advertise the route on both of the CSR in BGP. So let me just copy the config real quick. And then I just apply the CSR1. Okay, let me copy the other one. So after I've done those, to show IP interface brief. Okay, so the tunnel is up. That's good. I'm assuming this tunnel should be also up. Okay, that's good. Let's do a quick connectivity test to say the tunnel is up. Okay, tunnel is up. Okay, the tunnel is up. So now let's go back to the ASR. Do a show IP BGP summary. Now you should be able to see 4 neighbors. So the 88, those are the one that talk to the virtual network gateway, and that's like BGP1 I'm talking about. The BGP2 is here. It's 12 and 13. So if I do a show BGP all, okay, you can see I learned the routes 10.0.1.0, more specific routes from the 13 and 12 IP addresses, which basically are the tunnel IP address that's used at the remote end. And you can see I also prefer this 12. Actually, this is the CSR1, and 13, that's the CSR2. The reason to prefer 12, I think you should remember that, is because it's choose the lowest router ID. Okay, that's basically how the BGP path selection works. Also, you can see the AS number here is 65011. That's the CS, that means the CSR1. So now the connectivity should already be built. So let's check the connectivity, which we are not able to check before. Before we do that, let's also make sure we have set up this side. So I told you I already configured the BFD, I configured the HA, but let's check the route table. It has been updated with UDR to point to the CSR. Let's go to the route table. So that's a private subnet. I know it's a little bit confusing here, but actually I'm using the resource group. It's called HA-CSR-1.RG. So this is private route table. Let's take a look at the routes. Okay. The default route, I'm pointing to 1.5. Actually, that's CSR2. So let's change it back to CSR1. 1.4 actually it should be. Okay, let's update the route real quick. So for those subnet, I'm forcing them to use the 1.4 as the gateway. Okay, so it's automatically changed. Okay, it's using 1.4. So now if you come back here, let's do a real quick test. Okay, so you can see that actually the ping works. So basically, the on-prem side can ping the CentOS that's running at the application subnet. That's through the express route. So let's do a trace route to make sure it's traversing the CSR. 0.1.6 source bit 1. Okay, you can see the first hop is 12.0.0.2. So that's tunnel 1 that goes to CSR1. And then it reach out to the 10.0.1.6 directly. So it means this traffic is going through the CSR1. So I think we have successfully set up the configuration. So the CSR is able to encrypt the traffic that's over the express route and has been used as gateway to your application subnet. So let's do a failover test real quick because every people want HA, and I already set up the HA between the CSR1 and the CSR2, and you can find the other video that on my YouTube list that will walk you through the steps to configure the HA. Let's do a quick test. So let me also, because it is going through the CSR1 at this moment, let me just save the config real quick. So basically the HA, I think some people might not know how the HA works. So right now, the UDR is pointing to the CSR1 as a default gateway because you see the default route pointing to the CSR1 1.4. So if CSR1 failed, the CSR2 will be notified by this BFD down session. And then it's going to change the UDR or the route table to point to the CSR2. So the next hop is going to be 1.5. As you can see here, it's still 1.4. But if I reload the CSR1, it will be changed to 1.5. Okay, so because we're going to reload the CSR1, let's do a terminal monitor on CSR2 to see those logs. Okay, so let's do a repeat. Let's put repeat 2000. And then we're gonna reload the router real quick. Let's put 5000. It's better. Okay, now let's come here and do a reload. Okay. As you can see, I cannot get control to the router. It means it has been reloaded. Okay, so now the CSR2 has detected it failed, and then it do a replace route successful. So it has replaced route already. Let's come here. So as you can see, it's already changed to 1.5 actually. Before it's 1.4. So here, as you can see, there's no ping loss. So the switch over is really quick. It's still pinging actually. What I want to do is I want to verify the traffic is going through the CSR2 now. Since it's still ping, let's start a new session. Azure sorry. Let me restart this session. Okay, trace route 10.1.6 source 1. The reason this is a little bit slow, I think it's because there's too much ping going on at this moment. Okay, so now you can see it's going through a 13 subnet, so that's tunnel 2. Actually, that goes to CSR2, and then it reach out to 1.6, which is the VM. So if you do show IP address brief, as you can see, the tunnel 1 is already done already, and you only have the tunnel 2, which is 13 subnet. So let's do a quick recap. So what we have done in this video. So basically, we create the express route, we create a gateway subnet, we add a express route VPN connection, so that will link the express route circuit and also the virtual network gateway you created in the previous step. And then we create the tunnel between the two CSRs. So sorry, we create the tunnel between the ASR and the CSR, so it can establish overlay over the express route. And then we configure HA that's between those two CSRs. So if one CSR fails, the other CSR will take over the traffic. And I also do a reload of one of the CSR. As you can see, there's no ping loss. The switch over is pretty quick. The only catch I have mentioned about is about this static route. So you have multiple ways to do that. I recommend you take a look at this link. It will give you a better or detailed idea of what is the problem I'm talking about here. Thanks for watching.